Hello guys, today we are going to talk about writing the equations of lines that are parallel and perpendicular to a given equation. On yesterday you were taught how to find the slope of an equation when it is written in different forms. So we're going to need that skill today in order to be able to find slopes that are parallel and perpendicular. So here you can see that we have two equations that are exactly the same. On the left side here, we're going to write an equation that is parallel to this equation that goes through the point 8, -6. And on this side, we're going to write an equation that goes to that same point, but it's going to be perpendicular to this line. First thing that we need to do is we need to figure out first, what is the slope? We should recall from yesterday that this is in the form y equals mx plus b. So we know that we have a slope of 4. Now, because we have the slope and we have a point, we are going to be using the point slope form, which is y minus y sub 1 equal to m times x minus x sub 1. So we are going to take the information that we have, plug it into this formula, and find an equation that is parallel to this and goes through this point. So we know that this 4 is going to be acting as our m, because if they are parallel, they're going to have the same slope. This is our point, and we should recall that every point is made up of an x coordinate and a y coordinate. And in this case, we're going to plug these in for x sub 1 and y sub 1. All right, so I'm going to plug that in. So we're going to end up with y minus, and then for y sub 1, I'm going to plug in -6 is equal to, they're parallel, so I'm using the same m, which is 4, x minus, and then our x sub 1 is 8. So we have plugged in our slope and we have plugged in our point. And now we just need to do a few steps to get this into slope-intercept form. First thing I'm going to notice is that I have these two negatives here, so that's going to turn into y plus 6. We're going to distribute this. We're going to get a 4x minus 32. And then lastly, we want to get this y alone. So what we need to do is we are going to subtract 6 from both sides. So we will end up with y is equal to 4x minus 38. And this is the equation of the line that is parallel to the original line. I know that they're parallel because their slopes match, and it goes through this point. Now we're going to take this same line on the other side, and we're going to write an equation that is perpendicular. So perpendicular means that their slopes are going to be the opposite reciprocal. So we're not going to be using the same slope, but we must start by identifying the slope, which is 4, and we want to make that the reciprocal. So if m is equal to 4, then the perpendicular m, we do that by changing the sign and flipping. So remember, this is like 4 over 1. So we're going to change that to a negative. And then if we flip that, the reciprocal of 4 is 1 over 4. So this is the slope that we're going to be using. So -1 over 4 is perpendicular to 4. All right, we're going to start off with that same formula for point slope. These values up here, this is still our x sub 1 and our y sub 1. And the only difference is that we are using a new m value. We're going to be using -1 over 4. So we're going to get y minus -6 is equal to our slope. The perpendicular slope is -1 over 4. And then x minus our x sub 1 was 8. Same as last time, we can change that to a y plus 6 is equal to, I'm going to distribute that fraction. So we get -1 over 4x. Be careful here, double negative, that gives us a plus 2. And then lastly, we want to get rid of this. So we minus 6 on both sides. So we are left with y is equal to negative 1 over 4x minus 4. So this would be the equation of a line that is perpendicular to our original equation and goes through the point 8, negative 6.